everyone. So yesterday we were looking at increasing and decreasing functions. So we figure out that if the derivative of a function, so if the derivative of a function is more than 0, while the function is increasing, then increasing, so that means it's going up, increasing.
Yeah.
If the derivative of a function is less than 0, well, that means it is decreasing. The actual function is going down then, okay, decreasing. And then the special case, if the derivative of the function is equal to 0, well, that means at that specific point it's not increasing, it's not decreasing. The gradient is 0. Yeah, gradient is 0, and we call that stationary point. Stationary point. The main rules, it's not going up, it's not going down. Now, we can also take so-called second order derivative. It's basically when you have a function, for example, you have a function, let's say y is equal x cubed. So we can take a derivative of that. So we say dy by dx would be equal then 3x squared. And then we can take a derivative again. That's called order derivative. So derivative from that derivative. So we take that and take a derivative again. So we say, well, this is the second derivative, so we put 2. This is not squared. This means the second derivative in respect to the second x. This is notation. So these numbers here, they are not squares here. This is just a notation for that formula. This means we're taking the second derivative with respect to second x, and second x is this one, not that one.
Okay.
So, and we basically do the same thing. We just take this second derivative that we just got.
Yeah.
So that would be what? 3 multiplied by 2x. So that's 6x then. Yeah. So this is used in mechanics a lot. So if you think about it, let's say you have a graph of distance and time. So if this is time and this is distance, so let's say a body is moving like that. So for every 1 second, the distance increases by 1, let's say. Okay. So if you figure out the gradient of that line, what would that give you?
A positive
of that line, the old way.
Oh, okay.
The gradient would be equal to what in physical terms? So this is distance, this is time.
Oh yeah, so d over t.
Yeah, so if you take the gradient, so distance divided by time, that gives us what from your physics?
The gradient.
Yeah, but what does it actually mean in the real world? If you divide distance by time.
Oh, the speed.
The speed, okay? So theoretically, if you find the gradient of this line, that would give you a speed of a body, how fast it is moving. So we know how to do a straight line, that's GCSE stuff. Now we know how to find the gradient of any curve.
What?
This, yeah. If we know the actual equation, we can find the gradient at any point by finding the derivative, dy by dx. That would give us gradient, which is equal to speed in this case. We have distance by time. So if you took a first derivative, you got speed. Now, if you're taking a second derivative from that, so you are taking the gradient of that speed now. So think about it. So this is time, this is speed. So let's say we have a line like that. So now if you take the gradient of this line, well, that would give us what? We're going to find the gradient of speed, the rate of change of speed.
The distance?
No. How fast speed is changing? What is that?
Oh, acceleration.
Acceleration, yeah. So if you think about it, if you take the first derivative from that graph, you get speed. If you take a second derivative from speed, which is this one, you get acceleration.
Okay.
Okay, so without plotting any graphs, if you're giving the equation, so they say, well, the equation is like that. This is how the body is moving. Well, if you find the first derivative of that equation, that is your speed. And if you find the second derivative, well, that is your acceleration.
It's so easy to do that, you know.
Yeah. Well, this is what I told you at the beginning of the year. Looks complicated, but it's kind of very easy. When you write it down and you tell me without plotting any, what would be the derivative. So 3x divided by x squared. So they ask you to find the derivative, the first order derivative, and find the second order derivative.
Of each term?
Yeah.
Okay.
Oops. Not 3. Second derivative with respect to second x. So let's do the first one. So give me the, what do you think it is?
It's gonna be, I'm gonna.
So we probably have to rearrange it a little bit first. What did you say?
For the first one, the first derivative is 15x4.
Yes, good. And then we have this bit. So 4 divided by x squared.
Okay.
I'll try to rearrange it a little bit. So that you can find the derivative.
It will be minus 8. Actually, plus 8x minus 3.
Well, you were right first time, minus.
Oh, wait. Oh, yeah, minus 8x minus 3.
Yeah, so if we rearrange that bit here, so we have 4x minus 2. So 4 multiplied by minus 2, x minus 2 minus 1.
Yeah.
What is it? Minus
8x minus 3.
Yep. Good. So that's the first order, and now we need to find the second order derivative. So second derivative with respect to second x. That means we have to take the derivative of that thing. So what would that be then?
Plus 24x minus 4.
Plus 24x minus 4. How did you get that? Not
That's
really.
what
So we're looking at the first term, which is this one. What's the derivative of that?
Oh, I got, sorry, 60x cubed plus 24x minus 4. I just gave you the second answer.
Second answer, which is what?
Plus 24x minus 4.
Okay. Good. So that is that.
Yeah.
I mean, you can change that back into the fraction just to make it tidier, or leave it like that.
Yeah.
We can change it to 24 just to get rid of that minus.
Yeah.
Which is the same basically. Very good. So that's that, and then we have a second